only hope.
It helps if you take the lens cap off. We had a vibration and we had a scraping noise in the motor when it was spinning. Transmission has to be resealed, so I pulled it out. The scraping noise that you can see, when they built this adapter and this adapter to bolt to the motor, and they drilled and tapped it for the flywheel has been rubbing right there on this adapter, scraping the living snot out of it, actually rubbing aluminum into these bolt holes. And like I told Harry, there is a scraping noise and a vibration when this thing spins. Scraping noise we found. Vibration, possibly the buildup of aluminum here throwing this off. I'm just not positive. Should this not be perfectly round, may be a problem. What I think I'm going to do is unbolt this from the motor and bolt it to this flywheel, and then have the flywheel high-speed spin balanced. We're going to first sand off this aluminum. There's no room between the adapter and here. We're going to have to take this and probably turn this on a lathe and cut this down just slightly. If we take off 15 thousandths, probably 10 or 15 thousandths, I think we can get rid of the scraping noise. And if we high-speed balance it with the pressure plate mounted on it, then I think we'll be in good shape. But it's been scraping ever since the motor started to turn. We had scraping noises, and they've only made one voyage across the parking lot when the controller wasn't working properly at about a mile or two an hour, and 2 drives up our roadway a quarter mile each time. So there's only a half a mile approximately on this motor, and you can see how much damage the scraping's been doing. It's hard for me to get a good... Maybe that's pretty good. I'm laying on my back under here trying to get this, so... But you can definitely see the flywheel has been gouging this aluminum up, and it's been actually depositing aluminum onto the flywheel. I peeled some of it off in layers already, and I'm also hoping, even though aluminum's fairly light, I'm also hoping that contributed to the vibration problem. So I really don't want to take this apart again. So I'll pull the adapter, mount it on here, cut this on a lathe, and spin balance it with the pressure plate in place. Mark the pressure plate where it's going to be, and hopefully that'll do it. Because this motor, the motor itself, should have been balanced from the factory. There's no tight spots in the motor. Spins freely. No slop in the bearings. I mean, the motor is brand new, so the motor should be perfect. We'll just get all we can corrected, get that transmission resealed. In a couple of days from now, when the rest of the body work is finished, the car goes out and gets painted. So I want all this done as much as possible. We are also going to take these front coil springs. Those have to come loose. We're going to take them out, and we're going to cut one coil loop off the springs and reinstall them, because the front end of the car is still too high. We need to bring that down. We got brand new tires on. The car looks pretty good, but we need to drop that front end another inch to inch and a half, and then it'll look pretty sharp. We'll get some more shots as we get the flywheel fixed, get the springs dropped out, and we'll get back in a few hours. I got everything off. I got the bolts loose that hold this adapter on. And I'm hoping like crazy that there's a pilot or another alignment pin or something. Because if the entire drivetrain is dependent upon these 6 little screws, the first time we drop the clutch, we'll shear them suckers right off. So I'm hoping there's some more strength here than what I'm looking at. I'll find out as soon as I can pry this adapter off the back of the motor. We'll get back in a bit.
Do you think this chisel will work?
Okay, took the adapter off. Adapter is here. And you can see the size of the bolts that hold on the flywheel. And there are 6 of them. They're pretty heavy duty. These normally screwed straight into the back of the crankshaft. Okay? Well, I got to show you something here. I'll leave it up to the customer if he wishes to let people know who has built this, but I'm not impressed. This collar goes on the shaft of the back of the motor. I know we don't have much light here. A reflection of the sun coming in. So this collar is what these 6 screws, I got 3 in there now, 6 screws go into. They go right into a keyed collar. That's a keyway. So the collar fits on here nice and tight, and it's keyed. Okay? The adapter is not keyed. This adapter is not keyed on the outside. It's tapered. It fits up inside of here. So it's a tapered fit. But the only thing preventing this drivetrain or driving the drivetrain is that 6 screws right there. Look at the difference between what the factory had and what they intend to drive this car with. Now, this car has a lot of torque, around 50 horsepower, 12,000 RPM capable motor. If you get above 3,000 or 4,000 RPMs and drop that clutch, they're expecting these 6 little screws not to shear off. I don't know. I'm not impressed. Not when there was 6 hardened bolts like this from the factory originally, holding the flywheel to the back of the crankshaft. I think we're going to have to look into something else that keys to the back of that motor. I'm not sure how we're going to hold it on yet, but there's a keyway slot right there in the shaft of the motor. I don't know. We got to somehow slide onto that and attach to that in such a manner that it can't slide back and forth. Now, this is going to take some thought, and we're going to have to spend a little time doing some research. We'll call the factory tomorrow and see what they do out the back of this shaft here. But I'm not convinced that 6 little, I don't know what they are, 4.5 millimeter screws are going to hold the torque of this thing when somebody crams that pedal down to the floor and goes to take off. I was hoping it would do burnouts, and I'm now concerned that even under hard acceleration we could shear these off. So we'll get back after some research and see what we can do, but we got to correct this problem. Okay, I've looked this over some. This fits down in here. It's nice that we have a keyway, of course, to lock it to the motor, which is expected. Okay, I don't know if you can see down inside with the picture here. Oop, a little bit. What I'm going to attempt to do is the best that we're going to be able to do. Knock the bronze bushing out. We're going to cut the keyway. We're going to extend the keyway. cut it into this body right between these two bolts. When the key is on the shaft of the motor, it's going to come through here. We're going to cut the keyway through this housing, out through the front, right here, and we will put a larger keyway, a little longer keyway, coming right through this housing. So we just cannot depend on them stupid little screws to do this. And we will stake this on each side so that that keyway can't work its way out and get into the clutch mechanism or whatever. And we'll look at the motor. It looks as though this keyway could actually slide back on the motor and darn near disappear. So I'm afraid this wasn't as well thought out as, in my opinion anyway, as it could have been. But I believe we can fix it by cutting the keyway farther. So I'll knock the bushing out. We'll measure the keyway. We'll get a keyway punch, and we will take this someplace and have that punched out. Get a longer key. Figure out how far the groove goes on the motor and get a long enough keyway that it can't slide in too far, and we'll stake this out here so it can't come out and get into the clutch mechanism or fall out of place. And that should lock this adapter a lot more secure to the main shaft of the motor. And we'll get some shots of that as we reassemble it. Right now, we'll tear the transmission down and get some new seals put in it. Tear the front springs out and cut a coil off of each side. Okay, we mounted the adapter back here, back on this. Chucked it up with an internal chuck. And we've shaved the surface of this where the flywheel was hitting. We're going to cut out just a little bit farther here. We've cleaned this face up. We still have a reveal for these screws. So we want to back this out and just shave enough off to clean this up. So that it's smooth again, but not so far out that we mess up where the bell housing has to mount. So we've got a small ledge out here where the bell housing mounts. This is clearance for the flywheel. Should be in good shape. I'm going to cut out just a fuzz farther, and then we're going to call it quits. That should do it. Okay, now we got a nice smooth surface way out here. We're going to make sure that that we're cut far enough out so that the flywheel can't possibly rub. We're going to go meet with an engineering firm and a machine shop regarding the strength of that. Supposedly the tapered fittings are quite strong, and that doesn't necessarily rely on the screws, but you've got pressure from the pressure plate pushing in on that all the time, and if this heats up, heat changes the how much squeeze there is on that shaft, and things could come loose, and then you're depending on them tiny little screws
to not shear off, and I don't feel comfortable with that. So we'll get back in a while after we talk to a machine shop and an engineering company on what would be the best way to handle this. Friday evening, 7th of August. Notice that climbing in and out, putting weight and sitting on the rocker panels, kind of working on the car. These areas that Harry wanted completely sealed over were MIG welded, stitched. And we developed a crack in one of them. So we peeled them all out, and they will be seam welded all the way down and filled so that the metal's fused and we won't have to worry about any cracks. What I'm doing right now, I've removed his front spring. I took an old used spring. Ooh, glasses are falling. With the cutoff wheel, I've cut off about an inch and between an inch and a quarter, inch and 3/8 from this height here to the top of there. I guess I can measure that and see where we are, but it should be about an inch and a quarter from the top of here to the top of there. And I've taken the used spring so we don't cut up. Here's a good one here for a test. I just put it back in here. I don't know if we can see it very well, but I've just installed the used spring back in. I don't have the sway bar hooked up or anything yet, but we're going to put weight on it. We're going to see how it fits, how it looks, and how the car sits. So we'll do this trial. If we need a little more, I can nibble a little more off the spring. Kind of a time-consuming pain in the neck, but it's necessary to get the front end of this car back down. Most of the weight that was removed from the car was removed from the front and midsection. Engine, all the components, radiator, heater boxes, bumpers, door components. Lightened up the car quite a bit by taking the windows out and the glass and the regulator and all the guides, windshield frame. But unfortunately, a good bit of the weight going back in the car is behind the seats and in the trunk. So we need to get the front end back down, transfer some of that weight. We've done it with tires. We have smaller tires for the front than we do for the back, so we've done some of it there. And we're shaving the springs down, and we're going to try it. I'm going to do a reassembly here as quick as I can, drop it back down on the ground, and get a look at what it looks like with the spring trimmed as far as I have it now. And we'll try and get a shot of that here, if not tonight, tomorrow. And then if that looks good, measures good, I will cut the springs that came from the car that we've bead blasted and painted. I'll cut those down and reinstall them to this same size tomorrow. And then we'll have that hurdle out of the way. Okay, about 10-15 minutes later here, got the car back on all four wheels because it was jacked up on stands all the way around. I've pulled a measurement, and you can see that the distance between the top of the tire and the fender is smaller. The car is tilting towards the front. Now I've only done one side. The other side is 25 3/4 from the eyebrow edge here to the floor. And this side is 24 1/4. You can see from the front of the car that there's a definite lean to the left. So pretty much got the 1.5 inches that we were looking for. Not sure I want to go much more than that. The spring sets in there with some weight on it. The spring goes back level and even and actually looks good. Now, there is no gas shock back on this side. Being that they push open a little, it may raise the car a fuzz. I'm thinking that what I may do is, and I know it takes about an hour to hour and a half each time I do this, but I may want to shave another little bit off of that spring, put it back on here, and then see where we are, because I can I'm going to find out what we're rubbing on here, because the other side doesn't make that noise. So I'm going to have to everything's not bolted tight everywhere, but I'm going to have to find out what could be the bolt going through the sway bar, which is not tight. I'll tighten up a few more things and try that again. Make sure the spring's not rubbing any place. But we got pretty much the desired effect of about 1.5 inches. And I think that's going to be what we're looking for. So I'll get more things put back together. We'll get the other side cut down and we'll get another shot of it. Okay, we put a sample spring in the car. This one right here. We had that rubbing noise because this extension that comes out flat right here helps position the spring, and it was cut off on this one, so it didn't exist. So I cut down the original spring for the car approximately 1/8 inch shorter than this one. I cut off this flat piece from the original spring and I added it onto this one to give it a better positioning locator in the control arm. This is approximately 1/8 of an inch shorter, maybe 1/4. Part of the reason for that is Harry wants this kind of low, and the gas shock, when I filmed this, with this one in, the gas shock was not in, and they're Bilstein gas. And they do push up on the car, probably 40, 50 pounds or more of pressure. So I dropped this just a touch more. I'm going to go ahead and clean this up, prime it, and paint it, and get it put in, and then we're going to switch to the other side. It's Saturday about 11 o'clock in the morning. All right, we got the second spring cut down and a little short straight piece welded on it right there. I know that springs are not very liking to welding, and it very well may, if there's stress on that particular area, it very well could break. We're going to give this a shot. Springs are about 12¼ inches tall. The factory spring is about 13¾ inches. So we're about 1.5 inches cut off. And we'll see how that sets, because what you see is what you get. So one side's finished, the other side, this spring is for the other side. I'll put it together now. Okay, we got our new Nardi steering wheel in. Leather wrapped, black spoked wheel. Considerably smaller than the original.
Because the original was
by several inches, because the original was so big it laid on your legs. You couldn't hardly fit in the car.
Well, this does feel nice.
It's nice. It's a nice leather wrapped wheel.
Yeah, not bad.
Might look a little bit small in the car, but we'll see how it goes. Nobody's making in the U.S. at all an adapter for a Nardi wheel. So we're going to take this old steering wheel that he had, which is in just fantastic shape, and we're going to tear all this plastic off it. I'm going to cut these off. We're going to chuck this up in our lathe. Going to grab a hold of this collar right here as best we can in the lathe. Spin this thing down and clean all this garbage off it. And we're going to see if these screws can come out, if we can retap these holes. We're going to clean this all up, and we're going to make an adapter plate that mounts to here that will allow this to mount to the adapter plate with at least 6. Well, actually, I'd like to use all 6 of the holes. So we'll transfer that to an aluminum plate and try to screw that to these 3 locations. And then once we can mount this to that plate, we'll clear coat this because it'll be like a machined polished aluminum. And we'll see what happens, because the one fella I talked to told me that the adapter made in Germany is about $300. And I'm not sure it will fit this particular Nardi wheel. So I guess we'll just attempt to make one. We'll get back in a while after we get everything cleaned up.
Before I get going.
Just got the seats back. Seats are in. Give you an idea here of the contour match there. Headrest, a little bit of space, not a lot. This will be aluminum diamond plate cut down a little bit lower here and folded under. This, we're doing some more model work on this to pull a cast off from it. Customer doesn't want them overpowering the seats, so we brought the headrest bumps down a couple inches. They still stick up plenty, they just don't overpower the seats. So I believe this is the look. Well, this is the look he's going to get, so I'm hoping that's the look he likes. Get a shot of what it looks like from the front. Getting a little bit of a lot of light coming in from outside, so this is not the steering wheel that he will end up with, but I'm building a hub for that today yet. And we're working on door panels and some other trinkets inside, and final sanding and contouring the body so we can get the car in for paint next week. This is August 8th, Saturday. All right. There's the look of the car right there. The only difference, there's a controller and a grill for extra weight to go in the front end. Not a lot of weight. We're looking at 30 pounds. So this is the stance that the car is going to have. Both tire size and with the cut down springs. That's how she'll set. We got the seats in. We got the headrest model in. Windshields are not adapted to mount yet, so windshields are not in. This will give you an idea of the finished look, what we'll have here. I'll get a little farther away shot here from the roadway